Today what we're going to be doing is adding and subtracting like fractions. Alright, what does it mean to be like, combining like units? Okay, that means that the items have the same characteristics. Looking at these numbers here, 2 inches, 3 meters, 5 hours, and 2 minutes, none of them have the same units of measure. Can we add any of these numbers together? No, because their units of measure are not alike. Okay, so what can we do? Well, if I give you 2 feet plus 6 inches, what we can do is we can change the units of measure of one of those numbers so that they are the same. So what I need to do here is looking here at, let's say, feet. Okay, 1 foot is equal to 12 inches. Okay, so if I have 1 foot is equal to 12 inches, so isn't that true that 2 feet would then equal 24 inches? Okay, so now I can replace that into the problem. I can say 2 feet plus 6 inches is equal to 24 inches plus 6 inches, which in turn is 30 inches. Okay, so that's how we can add the two numbers together, provided that we change the units of measure so that they are the same. Okay, so if just like we have like units of measure in order to add numbers together, we also need to have like fractions. Okay, so what does it mean to be a like fraction? Well, let's look at this example. 2 inches plus 7 inches is 9 inches. Well, that's the same as saying, let's change it to fourths. 2 fourths plus 7 fourths is 9 fourths. Let me write something here. 2 fourths plus 7 fourths is 9 fourths. Okay, so when we have all these fourths here, what do we have? Well, that is saying that we have the same denominator. Like fractions, like units, means that we have the same denominator. So let's look here. If two or more fractions have the same denominator, then they're considered like fractions. So we're going to be dealing with like fractions this whole entire section. So we need our denominators to be the same, and then we add the numerators together. Okay, so let's look here. That's exactly what this says. If we have like denominators, like fractions, then we can add the numerators together, adding the numerators right here. Okay, same goes for subtraction. As long as we have the same denominator, we hold on to the denominator and we subtract the numerators from one another. Okay, let's do some examples. You try it, number 1, 7/15 plus 1/15. Okay, we do have like fractions, common denominators here, so 15. Okay, add the numerators together, we get 8/15. All right, so now how about 10/13 minus 5/13? We do have a common denominator of 13. Subtract the numerators. 5/13. Okay, you try it, number 2. We do have a common denominator of 20. Also, adding those numerators together, we get 10. Notice here, though, what we do need to do is we need to simplify your answer. Simplify answers. Okay, what does it mean to simplify this one? Well, this one has a common factor of 10, so that means that we can wipe out those zeros and we end up with 1/2 as the answer. Something I want to caution you about, though, is do not reduce back at this stage here. If you reduce back at this stage, if you look and you say, oh, I'm going to divide a 4 out of each, and you're left with 2/5, and then in the second fraction, you have, oh, there's a 2 common to each numerator and denominator. I'm going to divide that out and left with 1/10. Notice you can't add these two fractions together because they don't have, they're not like fractions, not like, so we can't add. So do not simplify too early, or then you'll get yourself stuck. Okay, so let's move on to part B. 18/25 minus 3/25. So common denominator, 25. 18 take away 3 is 15. So what's the common factor here? Common factor is 5, so you're left with 3 and 5. So here we get 3/5 as our answer. Okay, so now let's look at adding negatives with our fractions. Okay, so here we have a common denominator of 25. Negative 14 plus 4 is negative 10. So you have to remember how to add negative numbers together too. Both having a common factor of 5, so divide out a 5 from each, and we get 2/5. So here we have negative 2/5. Okay, how about the next problem? The next problem has a common denominator of 40, so we hold on to that 40, And now we have negative 17 minus 13. Adding those two values together, we get a negative 30. Be careful of both of them being negative. Okay, so those are two negatives. Now, simplify completely. Factor out a 10 from each, and you're left with negative 3/4. Okay, so there's our answer. Let's look at, you try at number 4. These have variables in it now. Let me rewrite it so that you might be able to see it better this way. The book writes it with the x off to the side like that, but really, this is what it's doing. It's 4x over 9 plus 8x over 9. So you can really look at it that way, and that might help you out a little bit in seeing that this is 12x over 9, because 4x plus 8x is 12x. Okay, now, is there a common factor between the two? Yes, there's a 4, or there's a 3 in each, so that leaves you with a 4 in the numerator and a 3 in the denominator. So we get an answer of 4x over 3. Okay, so that would be the answer. How about this problem? This problem really should have a plus here, so let me correct that right now. Okay, let's look here at negative 17b squared plus 11b squared. This is all over 30. So what do we get out here? What we get out here is negative 17b squared plus 11b squared, both having like terms there, so that we can add them. We get negative 6b squared over 30. Okay, common factor in each is a 6, so factor out the 6. You're left with a 1 there and a 5 there. So we have negative b squared over 5. Okay, so there we have it. Okay, so let's move on now and talk about adding mixed numbers. Okay, let's add these mixed numbers together. When we do this, what we are looking at is, look at the fractional part. 3/7 plus 2/7. When we add the fractional parts here, we're saying that this is 5/7. Okay, so looking at these, as long as we have a common denominator, then we're adding the numerators together. So what we have here is 5/7. Now add the whole parts. 1 plus 3 is 4. So there's your final answer, 4 and 5/7. Okay, let's move on to the next one. Looking here, we do have a common denominator here of 9. So that means our fractional part will have the denominator of 9. The numerator is 4 plus 2 is 6. Okay, adding together the whole parts, we get 5 plus 3 is 8. 3 plus 2, or 1 plus 2 is 3. I jumped ahead a little bit. Okay, what we have to do though here always is again simplify. If once you've added, you're left with a fraction like right here that needs to be simplified, you have to go through and do that. What's common to both of those? There's a 3 common. So we have 38 and 2/3 is our final answer. So make sure you reduce the fraction. Reduce fractions always. Okay, so let's go on to the next problem. The next problems here have little problems in them that I want to go over with you. Okay, so looking here at these fractions, what happens when we add 3/4 and 2/4 together? Well, we wind up with 5/4. Well, add the whole part. You get 4 and 5/4. We always want this fraction to be a proper fraction. Look at it. What is it? It's an improper fraction. We need to fix that. How can we fix an improper fraction? Well, improper fractions can always be written as mixed numbers, right? So let's look here. How can I rewrite this? Let me write it as this. 4 plus 5/4. Okay, we did that a while ago when we first learned about mixed numbers. Okay, what is this equivalent to? Well, that's the same as saying 4 plus, what is 5/4? 4 goes into 5 1 and 1/4 times. Okay, so it has the 1 as the remainder. All right, so this is the same as saying 4 plus 1 plus 1/4. So can't I add these whole values together, which is 5 and 1/4? So that's your real answer, is 5 and 1/4. So you may have to modify things if this is an improper fraction. So you changed your improper fraction down into now where this is now a proper fraction. So that's in great shape. Okay, so let's look at part C. Let's add these together. So 2/7 plus 5/7 is 7/7. Now adding the others together, we've got, that's 15 and that's 55. So 55 and 7 sevenths. What do you do there? 55 plus 7 over 7. So what is that? That's 55 plus, what is 7 over 7? It's 1. So this gives you a total of 56. Okay, so there we go. So that's how you go. Those are two possible glitches that you could have when adding the fractions together that you need to check for. Okay, so always make sure that you have an improper or a proper fraction when you've got your mixed number. Okay, let's go in and now subtract. Let's do some subtracting. Okay, so when we subtract, again, we're going to subtract the numerators from each other. Okay, so 3 sevenths and 2 sevenths. So 3 take away 2 is 1, so we got 1 seventh. 4 minus 1 is 3. 3 and 1 seventh. Okay, let's move on. It doesn't seem so bad, right? So let's move on. 3 eighths take away 1 eighth, so that's 2 eighths. 7 take away 1 is 6. Okay, always remember, simplify. Okay, that needs to be simplified. So there's a factor of 2 in each, so we get 6 and 1/4. Okay, how about this one? What do we do if we don't have a fraction here? Well, that's just like subtracting 0 from something, right? 5/12 take away 0, you're just going to have 5/12 there. And now 17 take away 13 is 4. So 4 and 5/12 is your answer. All right. Now this is something we have to talk about. This could be a potential problem. Right here, we need to make sure that our numerator, this number must be greater than the other denominator. Okay, so this number must be greater than this number. 2 must be greater than 7 in order to subtract. For instance, let me do this. 52 take away 27. What did we do in that case? Well, look at here. 7, you can't subtract 7 from 2. There's not enough there. So you have to borrow. Well, when we borrow, we add 10 to the ones place and gets us 12, right? And then we're able to go through the subtraction and get 25. So you're borrowing. Well, what do we do in this case when we have fractions? Well, let's go through this. Let's talk this through. So when we have fractions like this, we have this 5 and 2/9. This is equal to, oh, let me get my red pen out. I like my red better. So 5 plus 2/9. Let me erase that. 5 plus 2/9. Okay, so we need to make that 2/9 bigger. How can we make a fraction bigger? Well, we know that this could be 5 plus 1 plus 2/9. Okay, so or 4 plus 1 plus 2/9, excuse me. So we want to make sure that that's still equivalent, which it is. 4 plus 1 is 5, so we're still in good shape. So now what this 1 here, this value of 1 could be, is 9 over 9. Okay, if that's 9 over 9 plus 2/9, how many 9s do you really have? This is 4 and 11/9. So what we're doing is we're just rewriting this 5 and 2/9 in a different fraction. Yeah, that's wrong. That's improper fraction, but we need it to be that way. That's our way of borrowing. Okay, so this becomes 4 and 11/9 minus 2 and 7/9. So now, are we in great shape? Yeah, this numerator is bigger than this numerator. So now we can subtract. 11 take away 7. That's going to be 4/9. Okay, and then 4 take away 2 is 2. So we get 2 and 4/9. And that's how you get to your answer. Okay? So let's go through a couple of examples of this just to get ourselves practiced up on how to do this. Okay, again, numerator is smaller. The top numerator is smaller than the bottom numerator, so we've got to fix it up. How do we do that? All right, so again, I'll go through one more time slowly, and then I'll show you how to speed it up. Okay, so one time slowly, it would be 4 and 3/7 is like saying 3 plus 1 and 3/7. Okay, so that's still 4/7. Well, the 1 there, it's 3 plus 7/7 plus 3/7. which is 3 and 10/7. So that's what we're going to replace here. 3 and 10/7. Take away 1 and 5/7. Okay, so what does that give us? That gives us 5/7 here and 2 and 5/7. Okay, so how can we do this quicker? How can we do it the borrowing method? I'm going to show you the borrowing method. The borrowing method is, you always have to look at the denominator. That's what you're actually adding to the numerator. Let's look back at part A. At part A, when we look here and we go, oh, bad news, this one's smaller than this fraction. Bad news. What you're going to do is you're going to borrow. You're going to borrow and make this 3. What you're adding to this value here is 7, whatever the denominator is. So add 7 to 3 and you get 10. Notice here we got 10/7. So that's what we're going to be doing. So in order to borrow, we're going to borrow from here, from this 10, and we're going to get 9. But what we have to add to this is whatever number is in the denominator. 12 is what we're adding. Okay, so what we get out here is 9 and 13/12. Take away 3 and 5/12. Okay, so what do we have? What's 13 take away 5? That's going to be 8/12. And 9 take away 3 is 6. So now we do have to clean this up a bit because there is a 4 common to each. So we do get 6, and what happens when we remove a 4 from each? We get 2/3. So 6 and 2/3. Okay, so I hope everybody understands how to do those subtraction problems. Let's get into a couple of word problems and then we'll be finished. Okay, Shira is almost finished putting in the Guzman's new hardwood floor and has only to put baseboards around 3 short blank wall spaces. The measures of the 3 spaces are 5 and 5/16, 7 and 9/16, and 4 and 7/16. Okay, what is the total length? Total length of these 3 measurements. Total meaning add them all together. So that's a summation problem. Okay, so let's start adding. Denominators are all the same, so we're in great shape there. So we know our fraction is going to be all over 16. So what is 5 plus 9 plus 7? So 5 plus 7 is 12. 12 plus 9 is 21. So there we go. So that's how you can try to quickly do it. You can use your calculators. I'm not encouraging using the calculators though, but what is 5 plus 7 is 12 plus 4 is 16. Now, noticing here, what do we have going on here? We have got an improper fraction. So how many times does 16 go into 21? Well, 16 will go into 21 one time with how much left over? With 5 left over. So that would be 16, and then plus we have our fraction here is 1 and 5/16. So what do we have? 17 and 5/16. Well, 17 and 5/16 what? Inches. Make sure you don't forget the unit of measures, okay? That's very important. So 17 and 5/16 inches of, that's how much wood she needs to cover those spaces. Okay, let's do one more. Natalie made 2 custom base bookcases. One bookcase is 3 1/4 inches high, and the other is 32 3/4 inches high. What is the difference in the heights of the 2 bookcases? So, keyword here, difference in height. So we are subtracting 38 1/4 subtracted from 32 3/4. Okay, there's our problem. Notice what the big problem is this. The numerator in the top number is smaller than the numerator in the bottom number. So how did we do that? We borrowed, right? We said borrow from here. So take 1 away. What do we add to the numerator here? Add whatever's in that denominator. Add a 4. So what we get out is 37 5/4. Take away 32 3/4. Okay, so this gives us 2/4 here. Subtract 2 from 32 from 37, and we get 5. 5 2/4. Is this simplified? Yikes, no. That is going to be 5 1/2. So 5 1/2 inches. So there's a difference of 5 1/2 inches between her 2 bookcases. That's the end of the section. Good luck with this section, and I will see you next time.